Question 20 reads, the function f is defined by f of r equals r minus 4 into r plus 1 squared. If f of h minus 3 equals 0, what is one possible value of h? Well, what we're doing here, how we solve this question is, well, if I rewrite f of h minus 3 equals, I'm just going to replace, wherever there's r, I'm going to replace it with h minus 3. Okay, and so it becomes h minus, I'll do it in a different color, h minus 3 minus 4 into h minus 3 again plus 1 squared. And f of h minus 3, they already say is equal to 0. So this actually should be 0 on the left hand side. I can simplify this. H minus 3 minus 4 is h minus 7. And h minus 3 plus 1 is h minus 2 squared. Right? And this is very easy now. And maybe a few students may fall into the trap of expanding and then solving for the quadratic, but it's already in the factored form, meaning that I can equate both of these things that are in the parentheses to 0. So like h minus 7 equals 0, and h minus 2 squared equals 0. And the reason why we do this, if you're confused about why we equate both to 0, well, imagine a into b equals 0. Then a either has to be 0 or b has to be 0, because any number into 0 will equal 0. And so that's what why we do this, if you're ever curious about that. So h can be equal to 7, that's one possible value. And well, here, if I get rid of the root square by rooting both sides, and so h minus 2 equals, root of 0 is just 0, and so h equals 2. Okay, and so these are two possible values. 7 or 2 are correct values for this question.